This video is on section 4.4. It goes along with homework assignment number 27. In this video, we're going to take several logarithms that are added or subtracted, and we're going to write them as a single logarithm. This is just the reverse of what we did on the previous video. There's one thing that I want you to remember, and if you've copied this sheet off from your class notes, I have a note at the bottom, and it says if the log or the ln term has a minus sign in front, then that argument becomes a denominator. Now if you can remember that, this will be very easy. I'm going to go through the first four problems, which are just straightforward rule problems. There's nothing fancy in them. Now in this problem number 10, I have three logs. They have no base, so we understood that that's base 10, and we don't have to write that. Now everything is being added, which means the x would be multiplied with the y and with the z. So we have log x, y, z. Notice because they used log in the problem, I used log in my result. Okay, number 11, we're going to introduce a negative sign. I again have log for all three. I have the x added to the y, so we'll multiply. Then I have minus z. Now remember, we associate a minus with division, so we'll put the z in the denominator. This goes back to this rule at the bottom of the page. If the term has a minus sign in front, then that argument goes in the denominator. Okay, number 12. We're going to have one log. We have x minus y, so we're going to associate that with division. Now we have a plus sign, and with the plus sign, that would not put the last term in the denominator. It brings it back into the numerator. Think about this is that you have x being divided by y, but you're not dividing by z. Number 13, we have log, we have x minus, which means we're dividing by y. We have minus again, which I say is that we're still dividing by z. Now let's put a few, add a little bit to the elements using those two rules. We're going to use log base 5 in this one because that's what the problem has. Okay, we have an x. Now remember, this 4 came as a result of that x having an exponent, so we're going to bring it back up in exponent position. Minus means we're going to divide by y. This 3 is going to go back as the exponent, excuse me. Now remember, the minus told you to go to the denominator. Now we have a plus, which pushes you back up into the numerator with z. Remember the rule. The term following the minus goes in the argument in the denominator. Alright, number 15 has ln, so we're going to use ln. That's going to be ln2 plus means we'll multiply by x, minus means we'll divide by x minus 1. Now, number 16, we're going to have just a little bit different method for reducing it, so let's watch it. 1/2 times log base 3 of x plus 6 log base 3 of z. Now the 1/2, remember, tells me by it being written in front that it was an exponent. So I think to get started, let's remember that thought, but let's go inside these parentheses and take our two logs and write them as one log. So that'll be 1 log base 3. Now I have a plus sign here, so I'm going to be multiplying my argument. So that will be x, which would be multiplied by z, and this z has a 6 for an exponent. Now you remember that I said that all of this would be raised to this 1/2 power. Now one thing you are going to need to do at this point is look at that and see what you could do with it. Probably my math lab would want you to reduce it and distribute this 1/2. So that would be x to the 1/2 power and z to the 6/2 power. And you see already that that could be reduced again. Log base 3 of x to the 1/2, z to the 3rd power. Writing several logs as a single log, remembering that if you have a minus sign in front of a logarithm, that will push that argument into the denominator.